NASA has been silent about 3I Atlas. Now China suddenly redirects telescopes toward it. Same target, same day, same observation window. Why now? There are no wrong answers here. Your perspective helps us map what the community thinks. You're not commenting to me. You're contributing to the investigation. Even a short comment like A or 2 helps us map what direction the community sees. What do you think? 1, if this is coincidence. 2, if it's coordination. 3, if something triggered both. 3, IATLAS should be getting brighter right now, approaching closer to peak heating, solar radiation intensifying. Every comet ever studied becomes more active under these conditions. Instead, observations suggest it went dark. Tail gone. Coma disappeared. Activity dropped when physics predicted the opposite. Spanish facilities reported it first. Hawaiian telescopes confirmed independently. European instruments verified. South African observatories documented the same. Multiple independent facilities, different countries, different equipment, all seeing the same thing. Active one session showing clear coma and developing tail. Quiet the next, showing neither. The transition happened between monitoring windows spanning just days. Comets don't typically behave this way during approach to maximum heating. Temperature rises with decreasing distance. Sublimation should intensify. Gas production should create visible structures. That's what thermal physics predicts reliably. Until 3I Atlas apparently decided not to follow those rules. The change wasn't gradual decline, wasn't slow fade over weeks, active during one observation period, then quiet when telescopes checked again, like something switched off rather than gradually declining. What stands out to you? Reply A if you think natural shutdown. Reply B if something triggered this change. Here's where the information gap becomes noteworthy. NASA's Mars Reconnaissance Orbiter reportedly captured images of 3I Atlas on October 2nd, 2025, according to publicly available mission logs. Let's understand what that actually means. Mars Reconnaissance Orbiter carries HiRISE, the high-resolution imaging science experiment, the most powerful camera humanity has ever sent beyond Earth orbit. From Martian orbit, HiRISE resolves features smaller than 1 meter across. That's individual boulders. Surface texture, structural details invisible to any Earth-based telescope, even under perfect atmospheric conditions. At the distances involved during 3I Atlas encounter, HiRISE should have captured surface details showing formation processes, crater patterns from micrometeorite impacts, evidence of layering revealing internal composition, morphology indicating whether structure matches predictions for gravitational collapse of loosely bound materials, regional variations in surface properties, any characteristics distinguishing this interstellar visitor from typical comets. NASA confirms acquisition occurred. Data downloaded successfully according to telemetry records. File IDs exist in mission documentation. Everything worked according to design, but no image release after months have passed. Here's how NASA normally processes spacecraft imagery. The pipeline is well established and highly automated. Raw data downloads to Earth receiving stations. Initial processing removes instrument artifacts automatically. Calibration adjustments correct for known sensor characteristics. Quality verification checks ensure data meets standards. Then automatic upload to public archives through planetary data system. Timeline for typical observations? 2 to 3 weeks from capture to public availability. Sometimes faster for high priority targets generating public interest. The system is designed for transparency. Publicly funded missions. Data belongs to taxpayers. Researchers worldwide need timely access for studies and publications. Mars Reconnaissance Orbiter has been operating since 2006. Nearly 2 decades of continuous observations, tens of thousands of images released, Mars surface features, atmospheric phenomena, Phobos and Deimos monitoring. The pipeline handles everything routinely and automatically. These particular 3I Atlas images have exceeded 5 months without appearing in public archives. Researchers requesting access through normal channels report files remain unavailable. That timeline represents substantial deviation from standard processing. NASA referenced administrative delays, processing backlogs, and government shutdown effects as contributing factors. Those are legitimate explanations. Government shutdowns genuinely disrupt operations, personnel shortages, slow processing, review procedures get backed up, coordination between teams becomes difficult. Historical precedent exists for delayed releases. Mars Reconnaissance Orbiter data faced temporary delays during previous government shutdowns. Some datasets required extended verification when initial processing revealed unexpected artifacts needing careful analysis to separate real features from instrument effects. But typically those delays affect multiple datasets simultaneously. Processing backlogs don't selectively impact individual targets, while routine observations from the same spacecraft continue flowing normally. Other Mars Reconnaissance Orbiter data from the same time period released following standard timelines. Mars surface images, atmospheric observations, all appeared in archives on schedule. Only these specific 3I ATLAS observations face extended delay. What makes these particular images different? What triggers review beyond automated processing that handles thousands of observations routinely? If NASA delays data release, what's your take? A, for checking quality. B, for identified processing error. C, for something unexpected. If you want NASA or China to release the images, hit like. It pushes this into the algorithm. Here's where the pattern becomes genuinely noteworthy. Within 48 hours of NASA's capture window, China redirected 2 major observatory facilities toward 3I Atlas according to publicly available observation schedules. Let's understand what that coordination actually means. China operates several world-class astronomical facilities. Purple Mountain Observatory near Nanjing, one of Asia's premier research centers for solar system studies, advanced instrumentation for tracking near-Earth objects and cometary activity, fast radio telescope in Guizhou province, 500-meter aperture, largest single-dish radio telescope on Earth, capable of detecting extremely faint signals from celestial objects. Both facilities suddenly retargeted toward 3I Atlas during the same week. NASA's Mars Reconnaissance Orbiter captured close-range images. Observatory scheduling doesn't work casually. Facilities operate under intense demand. Researchers worldwide submit proposals months in advance. Review committees evaluate scientific merit. Approved programs get scheduled into observing calendars that optimize instrument efficiency and sky coverage. Changing those schedules requires compelling justification. Technical staff need reassignment from planned observations. Data processing pipelines need adjustment for unexpected targets. Approved observers whose programs get postponed need notification and rescheduling. Facility directors need explaining to oversight committees why resources shifted away from approved programs. This doesn't happen for routine targets. Doesn't happen without serious scientific rationale, convincing multiple levels of review that priority reallocation serves important objectives. China's facilities could observe thousands of objects visible from their geographic positions. Known asteroids passing through optimal geometry. Periodic comets approaching peak activity. Planetary phenomena. Stellar events. Essentially, unlimited targets competing for limited observation windows. Why redirect toward objects that appeared to be fading? Interstellar visitor that multiple facilities reported had lost tail and coma? Comet apparently shutting down when physics predicted intensification? International astronomical data sharing follows established protocols. Major discoveries typically get announced through International Astronomical Union circulars. Observatories coordinate through formal channels to avoid duplication and maximize coverage efficiency. Space agencies share orbital elements and ephemerides for tracking objects. But this level of synchronized retargeting within 48 hours suggests either formal coordination occurred or both agencies independently reached identical conclusions about observation priority based on their own assessment of earlier data. Countries don't typically coordinate smoothly on technology transfer or trade policy or territorial matters. Different strategic interests, different oversight structures, different funding priorities. Yet apparently both concluded independently or through coordination that 3I Atlas warranted immediate observation priority using major facilities despite the object appearing to fade. Why do countries usually avoid sharing telescope data? A, for political competition, B, for information control, C, for resource competition. Your comment becomes part of the timeline we are building. 3 scenarios attempt to explain why both space agencies elevated 3I Atlas to priority observation status. Let's examine each carefully with supporting evidence and challenges. Option 1. Fragmentation detected. What supports this? Cometary fragmentation is thoroughly documented natural process. Temperature gradients between illuminated and shadowed regions create mechanical stress through differential thermal expansion. Rotating nucleus experiences torques from asymmetric sublimation that structure must accommodate. Loosely bound rubble pile construction fails catastrophically when stress exceeds material strength. Historical examples prove this happens regularly. Comet Shoemaker-Levy 9 fragmented spectacularly into 21 distinct pieces before impacting Jupiter in 1994. Amateur astronomers actually discovered the fragmentation first, demonstrating how community observation contributes to understanding. Comet Schwarzmann-Wachmann 3 broke into multiple fragments during perihelion passages. Comet Linear completely disintegrated during closest solar approach in 2000. If 3I Atlas nucleus broke apart during October perihelion, that explains sudden behavior change in parent body. Piece separating removes mass, changes rotation rate, potentially exposes internal layers with different volatile content. Both NASA and China detecting separation would justify simultaneous resource dedication to tracking both parent body and fragment as they follow divergent trajectories. Fragments from interstellar visitor represent extraordinarily rare scientific opportunity. Interior composition normally hidden beneath surface layers, modified by space weathering during millions of years of travel. Understanding internal structure reveals formation processes in distant stellar system. What challenges this? Timing seems problematic. Perihelion occurred during October when thermal stress peaked. Observable fragmentation effects should appear during or immediately after maximum stress period. Instead, dramatic behavior changes manifested months later during March. Why would fragmentation become detectable so long after causative event? Delayed structural failure possible, but requires explaining substantial temporal lag. How to imagine this? Picture ice cube with internal crack. Apply heat. Crack propagates, but fracture doesn't complete immediately. Subsurface heating continues, conducting inward for weeks. Eventually reaches critical layer and structure fails catastrophically long after surface heating peaked. Pause. What do you think about fragmentation? Drop just 1 if you think this explains it. Option 2. Second interstellar visitor detected. What supports this? If both objects originated from same catastrophic stellar event, they could travel together as loosely associated pair through interstellar space. Stellar collision, planetary system disruption from passing massive object, something violent enough, ejecting multiple substantial fragments on similar trajectories. Those fragments maintain rough association through millions of years of travel before arriving nearly simultaneously. Separation distance in space might be vast, but arrival timing appears coordinated from Earth observation perspective. Statistical rarity makes this noteworthy. Confirmed interstellar objects remain extraordinarily rare. Only 3 ever detected by humanity throughout all observational history. 1I Oumuamua in 2017, 2I Borisov in 2019, 3I Atlas in 2025, having 2 simultaneously within inner solar system observational range either requires remarkable coincidence or suggests physical relationship through common origin. What challenges this? Probability arguments face obstacles. Random independent arrivals from completely unrelated sources following coincidentally similar trajectories through 3-dimensional space seems statistically unlikely without extraordinary supporting evidence, requires either accepting low probability coincidence or proposing common origin requiring specific circumstances that aren't frequently observed. How to imagine this? Picture 2 ships launched from distant port during same storm, travel separately across ocean for years, arrive at destination harbor within days of each other. Either remarkable coincidence or both following similar currents and winds from common origin event. Pause. The second visitor makes sense to you? Drop just 2 if this theory fits. Option 3. Behavior current models don't fully explain. What supports this? Multiple observational anomalies accumulate across different measurement types. Activity ceasing when thermophysics predicts maximum increase based on decreasing solar distance. Chemistry inverted from normal cometary ratios with carbon dioxide dominating 8:1 over water. Brightness variations during active phase appearing more regular than random fluctuations expected from chaotic sublimation. Extreme negative polarization measurements, unlike typical cometary dust properties. Each anomaly individually might admit exotic natural explanation. Collectively, they create profile, challenging, comfortable classification using only familiar processes documented in thousands of local solar system comets. What challenges this? Extraordinary claims require extraordinary evidence. Current observations, while genuinely unusual, haven't accumulated to levels most researchers consider sufficient for proposing processes fundamentally different from known natural phenomena. Burden of proof remains high for suggestions outside established frameworks. How to imagine this? Encountering animal displaying bird characteristics, mammal characteristics, and reptile characteristics simultaneously. Each feature individually explainable through evolution. Together, they create profile-challenging classification into familiar categories. Might represent exotic natural variation or genuinely different biological classification requiring new framework. Pause. If behavior doesn't match known physics, what does that suggest? Drop just 3 if this resonates. You are not passive observer. Your contributions shape investigation trajectory. Community analysis has proven effective repeatedly throughout astronomical history. Real example, Comet Shoemaker-Levy 9. Amateur astronomer David Levy co-discovered the fragmented comet in 1993 using relatively modest telescope. His observation led to one of the most important astronomical events of the decade when fragments impacted Jupiter in '94. Professional astronomers initially skeptical about impact prediction. Amateur persistence and continued observation proved crucial to understanding. Another example, 1I Oumuamua acceleration anomaly. Community discussion revealed assumptions in professional interpretation about outgassing that needed re-examining. Independent researchers proposed alternative explanations. Distributed analysis contributed insights beyond initial academic assessment. What can you contribute specifically? Publicly available data exists from observatories, making measurements accessible through online archives. Compare brightness estimates across different observation dates. Look for patterns others might miss. Check timestamps from facility reports. Note coordination patterns between observations. Track how activity descriptions evolved in published reports. Earlier observations showed clear coma and developing tail. Later observations reported both absent. Transition timing matters. Did any facilities capture intermediate stages? What does brightness data show during transition period? Even simple observations help. Write what stands out from this analysis. Note patterns in how information flows between agencies. Ask questions, revealing assumptions worth examining. Your fresh perspective might illuminate aspects disciplinary experts miss precisely because expertise creates filtering frameworks. Sometimes non-experts notice crucial details because they're not automatically filtering observations through established theoretical expectations. Your comment helps shape where this investigation goes next. NASA silent about images captured months ago. China redirects major observatories toward apparently fading object. 3I Atlas acting unlike known objects according to thermal physics models. Whatever this represents, we uncover it together through distributed analysis, through diverse perspectives, through refusing to accept silence when observations demand explanation. The story continues evolving. Any day, new data could emerge. Additional observations might reveal compositional changes. Those Mars images might finally release to public archives. Mystery could deepen with further anomalies or suddenly resolve through comprehensive explanation connecting all observations. When that happens, this community examines evidence immediately before official press releases frame narrative, before filtered coverage provides simplified explanation. If you want more people investigating this together, tap like. Say anything, even just 1, 2, or 3. Your comment keeps this visible. If NASA or China release something, we'll be here to analyze it first. Subscribe to join the investigation. 3I Atlas changed unexpectedly. 2 space agencies responded simultaneously. Multiple anomalies accumulate without satisfying explanation. Within those facts lies understanding we're working collectively to achieve. Comment. Which country you think will speak first, NASA or China? Reply with NASA, China, or no one